Okay, here we go. Last video for this unit, logarithmic equations. Very similar to solving exponential equations. Using the inverse for a log, which is an exponential, we call that to exponentiate both sides. So what you're going to do is you're going to make each sides of the equation the exponents for something that has the same base as your log. I know that sounds really weird, but you'll see what I mean when I write this out. Okay, so if we look at the first example, we have log base 2 of x. So 2 is the base for our log. What that means is when we exponentiate both sides, we are going to make 2 be the base for our exponentials on both sides, and this and that are going to be the exponents for that base. So it would look like this, where we would take 2 and raise it to the log base 2 of x, and then here we have 2 raised to the 9. So you can see how this and the 9 are the exponents, and that was what was originally in this equation. So that what happens is you take the 2 and raise it to the log base 2, those cancel each other out because they're inverses, and you're just left with x equal to the 2 raised to the 9th power. And then you can evaluate that quite simply, and you get 512. Another way of thinking of it, some of you might, the light bulb might be going off right now and saying, hey, wait a minute, isn't this right here just that written in exponential form? And the answer is yes, that's right. Exactly, that's what's going on. So you can see here's the base 2 raised to the exponent of 9 equal to x. So if you want to think of it that way, go right ahead. It doesn't matter. Either way, you're going to get the same answer. Okay, so let's go to the next one. We have the natural log of x equals 3. So because we're dealing with a natural log, that means we're dealing with base e. So when we exponentiate, we're using e raised to the natural log of x, and then e raised to the power of 3. These cancel. We're left with x equals e cubed, which we can easily figure out. So really, it's very simple. If you think about it, you're just taking a log and converting it to an exponential form, if you like to think of it that way, or you're exponentiating both sides with whatever the base is that your log is written in. Okay, let's look at some more complicated equations, because they do get kind of complicated, so they're not all going to be as simple as this, unfortunately. All right, so let's look at this first one. Before we do anything, we need to isolate this natural log of x. So I'm going to subtract the 5, and I'm going to divide by 2. So I get the natural log equals -1/2. And now I can exponentiate both sides. So I'm going to get x is equal to e raised to the -1/2. And calculate that on the calculator, we get 0.61. All right, next one. We have 2 times the natural log of 3 plus the natural log of x is equal to the 4. So there's quite a few ways that you can approach this problem, because it just all depends on how you view it. Some people like to distribute the 2. Some people like to actually evaluate the natural log of 3. Others like to divide by 2 first of all to get rid of that, and that's actually my preference. So I'm going to divide by 2 and get the natural log of 3 plus the natural log of x is equal to 2. Now, this is an interesting thing here, and this is something that you're going to have to be really careful about. When you are adding or subtracting logs, you cannot exponentiate each thing individually. You exponentiate an entire side as a whole. So what that means is we're going to use our property of logs to create one single log of a single quantity. So because this is the natural log of 3 plus the natural log of x, when you add logs, that's the same as writing the log of the product of 3 and x. And once you do that, now you can exponentiate both sides with the base of e, and we get 3x is equal to e squared. So x equals e squared over 3, which comes out to be 2.46. So I really want you guys to watch out. A lot of you will fall into that trap and try to say this is e cubed plus x equals e squared or something, and that's not correct. Okay? All right. Next one. This is probably by far the hardest one out of all of these. So when you look at it, we are subtracting two natural logs. So just like in the previous example, we're going to rewrite this as a single log of a single quantity. And since these are being subtracted, I'm going to take the x and divide it by the x minus 1, still equal to 1. And now, because it's a single quantity, I can exponentiate, and I get x over x minus 1 equals e to the 1, which is really just e, right? But now I have to solve for x. And this is a little bit more complicated because we have a fraction here that x is both in the numerator and denominator. So I'm going to cross multiply. And when I do that, I get x equals e times x minus 1. And then I'm going to distribute my e. So I get e times x minus e. The next step, I'm going to move this ex to the other side because I want to get the x's all together. So I get x minus ex equals a negative e. And since I'm trying to solve for x, I'm going to factor out the x from the left side, and I get x equals 1 minus e, and that still equals negative e. And now I'm going to divide by 1 minus e, so I get x by itself. So x equals a negative e divided by 1 minus e. And this is perfectly acceptable, but people in math land don't typically like to have this minus sign up here if they can avoid it. And so if I divide both numerator and denominator by a negative, I get e over e minus 1. These are exactly the same. They just look different, but the value is the same. Now, if they ask you to leave your answer in terms of e, then you would be done. If they ask you to round, then you're going to plug all this into the calculator, and you should get 1.58. All right, so there you have it. That's how you solve log equations. One word of warning, because these are log equations, when you evaluate them and you get x, it turns out, x could end up being a negative number, or it could be 0. And if that ever happens and you go back to your original equation, you're taking the log of something that's going to end up being a negative or a 0, you have to throw that answer away. So you cannot accept that as a valid answer. So always check your work, check your answers, plug them into the original, just do a mental check, plug it into the original equation, and make sure you're not taking the log of a negative number or a 0, because that would not work out, right? All right, you guys, we finally made it. We're done. Hip, hip, hooray. Bye. Bye.